So I spent a long time restoring an IBM 5170 case, but what about what was inside it? Well, this is that story. And it's not exactly a straightforward one. This strange, slightly pink goo that I'm scrubbing all over the board is very similar to navel jelly that you may have seen Adrian Black using. It basically eats rust and corrosion and leaves you with a very nice sparkly board. What I'm actually doing is chucking a standard dishwasher tablet into a sink. You might be asking why, but it's because a dishwasher tablet actually has anti-corrosives in it, which help make sure that the board isn't going to corrode any further. It pretty much neutralizes everything that could be causing a problem on it, and it should come out pretty sparkly. Giving it a good spray down with contact cleaner, which is basically isopropyl alcohol and some other chemicals. Then I'm going to give the whole thing a damned good dry using a hot air gun, and then I'll actually leave it in the airing cupboard for a couple of days just to completely dry. Sponsors of this video are PCBWay. They provide PCB prototype fabrication from as little as $5. They also have a huge library of shared projects, and if you're not confident with a soldering iron, you can get them to assemble them for you. PCBWay also have CNC machining and 3D printing services. All of this is available at PCBWay.com. Thanks PCBWay for sponsoring this video. The story so far, lots of problems, and this has made me check every single connection on the CPU and the interrupt controller master and slave and the timing chip, as well as a real-time clock. But before I got to any of that, I did what is known as the CH ready procedure, which basically puts the IBM 5170 into a mode where it's hung on the first instruction. So by actually holding the ready on the processor, we can actually then observe the bus and check to see we can read the first byte of RAM. And you can see on the ROM, you're able to see the first byte that's been and the address that's been asked for. So going through all that, you'll notice that there's quite a lot of socketed CPUs in this board. Socketed chips in this board. And it also has some bodges on the back. And that is fixing some of the damage that I created, because taking the CPU socket out was quite difficult, and that did lift some traces when I took it out. It's all repaired, it's all connected as it should be, and it's got a nice new Harris CPU in it. And I found a lot of bad logic in this board. So the death toll for LS logic so far in this board is this little array here. These are all the ones that test bad. There are some that I took out and I've effectively replaced them because they look like they were marginal. Occasionally I could get them to fail in the tester. One mistake I did make is I replaced some of the ALS with just LS. Now, having looked that up, there's actually quite a big timing difference between ALS, LS and F. So I've now replaced everything with the right thing. So the ALS are now ALS or faster. The Fs are now Fs. So that's good. The biggest difference is basically in the high to low response time is hugely different. On just an LS, you're looking at about 15 nanoseconds, whereas on the F and ALS, you're looking at around the sort of 3.92 milliseconds, somewhere around that ballpark. Hugely faster. And obviously, where that's used in part of the timing circuit to refresh RAM, so on, or is kind of a composite logic to do some of the address decode, it has to be quick because you've got a gate-to-gate hop for everything to get to where it needs to be. So I'm going to power this on. We've got an Oak Technology 1990s, early 90s VGA card, which is 16-bit. This card will actually run in an 8-bit slot. I haven't worked that out yet. It just does some magic. Postcard, just so I can see it is actually doing what it's supposed to do. It doesn't always behave first time, but hopefully we should see it do something. There we go. It still says 7876. On the Quantel BIOS, the 78 that it's got stuck on is somewhere around installation of interrupts and DMA. $512K, okay. VGA BIOS. Diskette error, expected. System options not set, expected. Diskette error. All technically I need to do is put a diskette controller in. Non-standard floppy controller, it does seek, but then hangs in the same place. And we've got 40, 36, so it's got to 40. Again, 40 points to interrupt DMA. So the only bits I've not dug into are the DMA circuits. Everything looks logically okay. There's nothing on there that's outside of TTL logic levels. So what I'm thinking potentially is that I'm going to have to remove some more chips and socket them so I can test them and see whether they're working or not. And potentially just swap them out anyway with brand new or known good ones. So that's what I'm going to try doing next. I'm going to take these three chips out, put sockets in, test them, potentially just replace them, prove that it's not got any worse or better, and we'll see how we go.
We have the tools, we have the talent.
Do you ever wish that sometimes you could freeze frame a single moment in your day, look at it and say, this is not my life?